Now we continue the next point, electric potential. Now how we explain electric potential? First we consider a point charge plus Q at the point O. That charge is surrounded by the region of electric field. In that region, we choose a point A which is at a distance r from the point O. At that point, we find the electric potential. Here, if we are considering the point charge is plus Q, and if that charge which produces electric field, that electric field direction is away from that point. If another positive charge is moved against the direction of electric field, then what happens? Work is done. That work done is against the direction of electric field. Since direction of electric field is along positive direction, and if charge is moved from infinity to a given point P, that work done is against the direction of electric field. In that case, the charge gain potential energy. Charge gain potential energy in the first case. Secondly, if we say that the point charge is negative, it also surrounds the region of electric field. But what is the direction of electric field? Is directed towards that charge. If we considering if the positive charge is moved in the direction of electric field, that direction of electric field is negative x direction, and if the charge is moved which is already at the infinity, is moved from infinity to a given point P in the direction of electric field. Here also work is done by an electric field, but the charge loses potential energy. Hence remember, if we considering the positive charge at point O and another charge is a positive charge, then that charge always gain potential energy. On the other hand, if point charge is negative, another positive charge is moved from infinity to a given point, that time charge loses the potential energy. In both cases, work is done if charge is carried from infinity to a given point. Hence, how we define the electric potential? Electric potential at a point. Which point we choose here? At the point A or P. In an electric field. That point is we choose in an electric field. Hence, electric potential at a point in an electric field is defined as the amount of work done in moving a unit positive charge from infinity to a given point against the direction of electric field. That electric potential is positive since it gains potential energy. That potential energy is the ratio of work done per unit charge. Electric potential is a scalar quantity and we write its unit using that definition, V equal to W by Q. Work done we measure in terms of joule and charges. Coulomb, hence SI unit of electric potential is joule per coulomb or volt. The next point is that we find the electric potential difference between the 2 points. For that, we consider the same figure, point charge is at the point O. The two points we choose along that direction, A and B, these are separated by very small distance dr, and B is separated at a distance r from the point O. Means the two points along in the region of electric field which are at a distances equal to r and r plus dr. Suppose the positive test charge which is moved from infinity to a point A. Then how much work is done? WA. Hence, what is electric potential at that point? VA is equal to WA divided by Q0. Since Q0 test charge is moved from infinity to a point A. Similarly, we also find the electric potential at the another point. At that point also, this same test charge is moved from infinity to a point B. Work is done. That work done we call WB. And therefore, the electric potential at point B in terms of work done is WB divided by Q0. Then what is potential difference between the 2 points? We take VB minus VA equal to WB minus WA by Q0, or WA minus WB we call this is the work done between the 2 points A and B. Hence, WAB by Q0, where WAB, this is the work done in between the points A and B, is nothing but force into displacement. What is the force? Force we have to calculating here, since electric field intensity or electric field is defined earlier. It is the ratio of force per unit charge. Therefore, what is force? E into Q. Hence, we have to simplify that term. That charge we write Q0, positive test charge. Hence, work done in terms of electric field is VB minus VA is equal to Q0 E into dr. Q0 cancel, we get E into dr. Hence, VB minus VA, it represents the potential difference between the 2 points A and B, that we call very small potential difference due to small displacement dr, that dV is equal to E into dr. Now, this is simplified form of the equation. If we calculate the potential difference between very small region where the 2 points which are separated by the distance equal to dr. Hence, dV is equal to E into dr. In that case, if we suppose A point is at infinity, A point is at infinity, then what is potential at that point? The potential at infinity is always 0. Therefore, VA is equal to 0. Then remaining term is only the potential at point P. Earlier equation we use VB minus VA is equal to E into dr. But here VA, that point is at infinity, therefore potential at that point is 0. Remaining term is VB. Hence, that VB is equal to, we have to integrate from infinity to given point. Hence, integration infinity to point B must be E dot dr. That equation we also take into consideration for solving the next terms. Also, we remember here, if the work is done when the charge is moving from one point to another point on equipotential surface. Equipotential surface means at each and every point on that surface, electric potential must be same. And if electric potential is same at every point, that surface we call equipotential surface. In such a case, what is work done in that case? Work done in taking a charge from one point to another point along any path is always 0. Now, at specific point, we have to find electric potential, hence potential due to a point charge. How we derive that term, potential due to a point charge? In the same situation as we defined earlier, we select a point charge plus q at the point O. Its surrounded region is electric field. In that region, we select another point P, which is at a distance equal to R. And suppose what is the direction of the electric field is positive charge. Field is directed away from that point. Hence, the direction is outward direction. This is the direction of electric field. We first find what is the magnitude of electric field at the point P. Magnitude of electric field at point P. If that point P is at a distance R from a given point O. What is the magnitude? We again use the earlier definition, electric field. How we define earlier? Electric field is the ratio of force per unit charge. How we calculate force? If the two charges separated by the distance r, the force of attraction or repulsion between the two charges is directly proportional to the product of two charges divided by square of distance between them. Coulomb's law. Hence, F force, that force we find from Coulomb's law, and at the point P we say this is another charge, that is Q0. Then what is force? Q into Q0 divided by 4 pi epsilon 0 into R square. And from the actual definition of electric field, it is the ratio of force per unit charge. Hence, charge Q0, numerator and denominator term get cancelled, and we get simplified Q divided by 4 pi epsilon 0 R square. This is one of the equation we get here. If we know the magnitude of electric field at point P, then what is potential at that point? Again, we use the definition, earlier definition, the electric potential at a point must be equal to integration from infinity to r, since the charge which is carried from infinity to a point, given point, that point is separated by the distance r from the point charge. Hence, we use earlier definition, that equation V is equal to integration E dot dr. Here, what is dr? Dr is the displacement of the charge. And what is E? Electric field. If dr is the small displacement of the unit charge and that displacement is directed towards the point O, means we say here the point P is shifted towards the point O with the very small separation dr. And E is the intensity of electric field or electric field that is directed outward, means along positive x direction. Therefore, what is angle between E and dr? We take the dot product. Angle is theta is to be, both are opposite in direction. Electric field is along positive x direction and the point P is shifted towards the point O with how much displacement? dr. Both are opposite in direction. Hence, angle is taken 180 degree between E and dr. Therefore, we find E dot dr. What is E dot dr? Firstly, use dot product. E dr cos of theta. What is theta? 180 degree. Cos 180 degree minus 1. Hence, E dot dr we get minus E dr. Hence, we put this value in that equation. Which is that equation? This is another equation. V is equal to integration infinity to r E dot dr is equal to minus infinity to r E dr. What is E here? E is the magnitude of electric field at point P. That is Q divided by 4 pi epsilon 0 into 1 divided by r square. Hence, we write constant term outside of the integration. V is equal to minus Q divided by 4 pi epsilon 0 into infinity to r integration infinity to r dr by r square. What is integration of 1 by r square? Minus 1 upon r. Limit is r infinity to r. Upper limit minus lower limit. Hence, the integration part becomes minus. Minus minus plus. Then what is the term remaining? V is equal to 1 divided by 4 pi epsilon 0 into Q divided by R. And that is the required term which we have to find at a given point in the region of electric field. The electric potential at a point in the region of electric field is V is equal to 1 divided by 4 pi epsilon 0 into Q divided by R. When we get that equation, if the point charge at O is positive and if the point charge at O is negative, then what happens? Since at the negative charge we know that electric field is directed towards the charge. Direction is different and therefore the electric potential at point due to the negative charge must be V equal to minus 1 divided by 4 pi epsilon 0 into Q divided by R. Hence, in the today's lecture, we have to find what is electric potential. We define the electric potential. It is defined as the amount of work done in moving unit positive charge from infinity to given point against the direction of electric field, and it is the ratio W by Q. It is scalar. Unit is joule per coulomb or volt. Then we find what is electric potential at a point due to point charge. If that point charge is positive or negative, that we are finding here. If it is positive, we get the electric potential at O is 1 divided by 4 pi epsilon 0 Q by R. If charge is negative, we get minus 1 by 4 pi epsilon 0 into Q divided by R. And that is the result of electric potential. Thank you.